Hello, young math padawans. It's Mrs. Angel with today's lesson on solving equations with variables on both sides. Our goal here will be to use the properties of quality to take an equation that has a lot of terms, get it down to a single term and a single term, so that the equation itself is pretty easy to solve. So let's go ahead and grab your notes and let's get started. Okay, so like I mentioned in the intro, we're solving equations with variables on both sides, and our goal is to use these properties of quality to create an equation that you just get down to one term on each side. Because if you're down to a single term and a single term, it's actually either your work's going to be completely done, or all you have to do is use a division or multiplication property of equality, and you're pretty much done solving. So let's look at what this actually, looks like when we're solving an equation that we feel more comfortable with. So we're going to go ahead and do the first example here. 2x plus 4 equals 10. If you want, go ahead and solve the equation on your own now. Okay, so what I like to do every time I solve an equation is I put a line down the middle of my equal sign, because that keeps both sides of the equation separate, and that way I don't lose how many terms I have on each side. Now, you have options here on this first one. You could either choose to divide all terms by 2, or you could choose to subtract 4 from both sides. Both of those are good properties of equality that would allow you to solve. Now, the most popular one, I will say, is to subtract 4 from both sides, so that's what we're going to go ahead and do first. We're going to subtract 4 from both sides of this equation, creating a 0 term out of the 4 on the left. So notice that we've now gone down from having originally 2 terms on the left down to a single term. That leaves us with a 2x on the left, and 10 minus 4 is 6 on the right. Now let's think about what we've actually done. We have now taken an equation that originally had 2 terms on the left side and 1 term on the right side, and we have used the properties of equality to get it down to a single term and a single term. The only term left on the left side is 2x, that's 1 term. And on the right, we've gotten down to just 6. So we've actually met our goal on the first equation by choosing to use the subtraction property of equality first. Now, why is this important? Well, because after this, it's pretty simple to solve. You're just going to use your division property of equality to divide both sides by 2, creating a big 1 factor, and we're left with x equals 3. We can do a quick check off to the side. So this is our solution to the equation. Now let's see if we can apply this same concept of getting it down to a single term and a single term on the second example. Now, if you would like to try this on your own, again, you can go ahead and do so now. Let's go ahead and go over this. So this equation looks almost identical. The problem here is that we have a 2x plus 4, but then on the other side of the equation, we have 10x and not 10. So let's see what changes when we solve this. I'm going to put the line down the middle of my equal sign, again, just to keep everything separate, and here we go. If my goal is, again, to get it down to a single term and a single term, then I'm looking at this left side of the equation, I'm going, one of these 2 terms has got to go. But which term is it? Well, let's say we start off the same way that we did the first one, by subtracting 4 on both sides. Here's the problem here. Yeah, I've now gotten the left side of the equation down to a single term because 4 minus 4 is 0. But 10x minus 4 is just another expression. Those aren't like terms. I can't combine them and say that it's 6x. This would just become 10x minus 4. And what we've really done is taken 2 terms on the left, and now we just have 2 terms on the right. So we didn't really get it down to a single term and a single term. We just kind of created a new equation that now still has 2 terms on one side. So even though that is technically an equivalent equation, it doesn't help us reach our goal. And then you could come in here and try to divide everything, right? Like that's totally fine. But then you're left with x plus 2 equals 5x. And again, our numbers got smaller, but we still have 2 terms on that left side. And if we're trying to get down to a single term and a single term, that's really not helping us accomplish our goal. So there's one thing we haven't tried yet. We haven't tried creating a 0 term out of the 2x, meaning completely removing that term. Now, division won't do that. Division makes a big 1. In order to do this, we have to use either addition or subtraction. So I don't know about you, but 2x plus 2x definitely doesn't equal 0. I'm going to go ahead and subtract 2x from both sides. Now what this does is it creates a zero term out of the variable term, 2x, and now I'm down to 4 on the left side, a single term. And on the right side, 10x minus 2x is 8x. So if you think about it, we have now accomplished our goal. We have a single term on the left, 4, and we have a single term on the right, 8x. Why is it that we want to do that? Because now it becomes a lot simpler to solve. All we have to do is divide both sides by 8, because that would create a big one factor, getting x by itself. And 4 divided by 8 is 0.5, or I like to leave it as a fraction, 1/2. And then we can go ahead and check. And 1 plus 4 is 5, so we know that our answer here is the correct solution. So let's keep that in mind. If you can use your properties of equality to get your equation down to a single term and a single term, you can pretty much solve any equation that's thrown at you. So let's look at our first example. Example 1, 5x equals 14 minus 2x. So if you would like to try this example on your own, go ahead and do so now. Great. Let's see how we did. I'm going to start by putting the line down the middle of my equal sign. And then again, my goal is to get it down to a single term and a single term. So what's standing out to me is that I have 2 terms on the right, meaning one of these 2 terms has got to go. I have to make a zero term out of one of them. What's also standing out to me is that the term on the left has a variable. So I'm thinking if I try to make a zero term out of this 14, it's probably not going to work because I can't combine a variable term and a constant. So let's try instead to make a zero term out of this negative 2x. And I do highlight that because the subtraction sign is equivalent to adding a negative. So when we look at that term, we're thinking of it as a negative 2x. So to do that, I'm going to go ahead and add 2x to both sides. That creates a zero term, which now I do believe we've met our goal because 5x plus 2x is 7x. And 14 minus 0 is 14. So if you look, we have now met our goal. We have a single term on the left, 7x, and we have a single term on the right, 14. Why did we want to do that? Because now it's fairly simple to solve. We're just going to divide both sides by 7. That creates a big one factor. And now we're left with x equals 2. Let's do a quick check just to be sure. So we know that 2 is the correct solution. Let's take a look at another example that's a little bit tougher. Okay, here is example 2. 8x minus 4 equals negative 2 plus 6x. As always, if you would like to try to do this on your own, go ahead and do so now. Great. Let's go through it. So again, first thing I'm going to do is put the line down the middle of my equal sign. So here's what I noticed. The left side of the equation has 2 terms, but the right side of the equation also has 2 terms. So that means I'm going to have to create zero terms twice. I'm going to have to do it with one of these on the left and one of these on the right. Now, you could technically do this 4 different ways. If you notice, we have a combination here of variable terms, 8x, and a positive 6x, and integer terms of a negative 4 and a negative 2. So you have 4 possible options. You could subtract 8x from both sides, add 4 to both sides, add 2 to both sides, or subtract 6x from both sides, because all of those would create zero terms out of one of these. Now, personally, I prefer to create a zero term out of the variable first, because what that does is it collects all of your variables to one side. With that in mind, I also try to avoid working with negatives. In other words, I wouldn't come to this equation and just subtract 8x from both sides, because that would create a negative term. And even though that's totally fine, more mistakes happen with negatives. So I actually think about this ahead of time, and I'm going, all right, if I'm going to create a zero term out of these variables, I'm going to do it with 6x. I'm going to subtract 6x from both sides, because that creates a zero term. But now 8x minus 6x is a positive 2x, and that's a much simpler equation. So what did I just do? I have now gotten the right side of the equation down to a single term, but the left side of the equation still has 2 terms. So noticing that the right side is an integer, -2, I'm going to make a 0 term out of the -4. Add 4 to both sides, 0 term, and now I'm down to 2x equals 2, and look at that, I have accomplished my goal. I am down to a single term on the left, 2x, and a single term on the right, 2. Why was that important? It's a lot simpler to solve now. Divide both sides by 2, because that creates a big 1 factor, and our final solution here is x equals 1. Let's do a quick check. So I know that x equals 1 is the correct solution to this equation. Last example, definitely the toughest one so far. All right, final example in today's video. We have 2 times the quantity of x minus 4 equals, on the other side, 6 plus 2 minus 3x. So we're now bringing in some of those concepts that we learned in the previous video of, we have like terms on the same side, we have an expression with parentheses, etc. So go ahead and try this one on your own now. Great, let's go over it. Line down the middle of my equal sign is always my first step, and then I'm just going to talk about what I see first. On the right side, it's a lot easier to notice that I have 3 terms, 1, 2, 3, and then I do also want to point out that we have some like terms, 6x, and the minus 3x. So there's something I'm thinking there about how I can maybe get from those 3 terms down to 2. On the right side, we actually only have a single term, but that term also has a group in it. In other words, we have this x minus 4 inside of parentheses. So I'm thinking to myself, how can I go from this single term into 2 terms, but no parentheses? So those are all things that are going on in my mind. So let's get started. First thing that I'm going to do, on the left-hand side, how do I get that single term of 2 times in parentheses x minus 4 into 2 separate terms without parentheses? The most common way to do this is using the distributive property. So here we go. 2 times x is 2x, and 2 times 4 is 8, and I am maintaining that it is a difference of subtraction. So now what that has done is I've gotten rid of the parentheses, and I have 2 terms on the right side of the equation. And as I mentioned before, we have these like terms. We have this 6x and this minus 3x. So we can combine those because they're on the same side. Now, this is not how we do it. We do not add 3x to both terms. That's a property of equality. If I'm adding 3x on the left, or on the right, I have to add 3x on the left too. You can't just add it twice on the same side. Now that's a property of equality. You have to do it to both sides. So instead, I'm just going to combine them as I see them. 6x minus 3x is 3x. So we now have 3x left over and the plus 2. So now I have it down to 2 terms on the left and 2 terms on the right. So now I have options again. I could subtract 2x, I could add 8, I could subtract 3x, I could subtract 2. Again, I like to think ahead. I want to get all my variables to one side, and I want to avoid negatives. So which one do you think I'm going to do first? I'm going to subtract 2x. That collects all my variables to one side, and I avoid having to deal with pretty much any negatives. Let's see what that leaves us with. So it makes a 0 term on the left, so I'm left with -8, which is a single term. I like that. 3x minus 2x is 1x, which, you know what? I could do that better. 1x is just x, because 1 times x is x. That was pretty simple. And plus 2. So I'm really close. I've got 2 terms left on the right-hand side. The left-hand side is already down to a single term. So now, let's see, I'm going to create a 0 term out of the plus 2, because the other side is a constant, and that leaves me with -10 equals x. So I have accomplished what I sought out to do. The left side is a single term, -10. The right side is a single term, x. And here's the nice part. Because 3x minus 2x is 1x, or just x, I am done. I don't have to do any other steps. How amazing is that? I'm super done. That's awesome. Let's go ahead and check. 30 is -28, so that goes to show my solution was correct. Yay! Okay, so let's just do a quick recap before you leave and start working on problems on your own. Number one, the goal is to use the properties of equality, addition, subtraction, multiplication, division, mostly addition and subtraction, to create an equation that has one term on both sides. If you can get it down to a single term and a single term, your work's going to be pretty simple from there. If you have the option, please try to create a zero term using the variables first. That's just an option, but it's, again, what I like to do. I like to collect my variables to one side. And again, it's always probably a good idea to avoid those negative coefficients. There's usually a way to avoid negatives. I suggest going in that direction. Finally, and most importantly, make sure that you're trusting your work as you go along. As long as you're using the properties of equality correctly, you really can't go wrong. And always, 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 always check your solution, because that's how you know that you actually did all of that work correctly. So that's it for today's lesson. I will see you next time.